Welcome back, Cosmic Explorers. Are you ready for your top 5 countdown? I'm Caroline, and today we're counting down our favorite moments from this unit to help you prepare for your unit assessment. Along the way, we'll be looking at viewer questions that students just like you have sent in. Let's jump right in and get this countdown started. Coming in at number 5, how it all began. And by all, I really mean all of it, our whole universe. Nearly 14 billion years ago, all of the matter of the universe was contained in a single point. For reasons that scientists are still trying to understand, space itself suddenly exploded in an event often called the Big Bang. Matter quickly began moving apart as the space containing it stretched at a rapid pace. This matter eventually took the form of atoms that we know today, and from these atoms, stars, planets, and galaxies would form, including our own. Let's look at a question we received about this topic. Pamela from Puerto Rico writes, "We learned that the universe is currently expanding. Is this expansion related to the Big Bang?" Good connection, Pamela. Yes, the current expansion of the universe is the direct result of the initial expansion that the universe experienced when it first formed. That one dramatic event set in motion an expansion that still continues today. But we don't understand all of it just yet. Data suggests that the expansion is actually speeding up, possibly caused by something cosmologists refer to as dark energy. This is a major area of current research in astronomy today. At number 4 on the countdown, let's revisit the structure of our universe. Matter isn't just randomly scattered through space. The common theme that appears again and again is that matter tends to clump together. It starts with hydrogen clumping together to make a star. Then stars are drawn together in galaxies. Galaxies group together into galaxy clusters and even superclusters. Between all of these clumps of matter, vast voids with no matter at all. These clumps exist because gravity naturally draws matter together. Let's look at a viewer question on this topic. Will from Wyoming writes, "Do galaxies within the same galaxy cluster get farther apart as the universe expands?" Good question, Will. Just like galaxies themselves don't get bigger, the galaxies within the same galaxy cluster also don't drift apart. This is because they are gravitationally bound. If you were to think back to our balloon model, entire galaxy clusters could be represented by these sticker dots. Only distant galaxy clusters that are not so tightly bound by gravity are being separated by the universe's expansion. Coming in at number 3, do you remember learning about stellar life cycles? What processes are involved in the birth and death of stars? Stars are born as a direct result of gravity gathering more and more mass together in a stellar nebula, which causes the gas to heat up. Eventually, it gets hot enough to begin nuclear fusion, and a star is born. But fusion requires fuel, ideally hydrogen, and this fuel will eventually run out. Stars can make do with fusing a few other elements like carbon and oxygen, but once those are gone, the star dies, either fading away quietly as a white dwarf if it's small, or erupting violently in a supernova explosion if it's large enough. Let's see what our viewers are wondering about for this one. Tanner from Tennessee asks, "What is a binary star system and how does it form?" Well, Tanner, if we're going to compare stellar formation to human birth, a binary star system can be thought of like twins. As nebulae condense and collapse to form stars, sometimes a region of the molecular cloud fragments into 2 or more forming stars. If these 2 regions remain within about 600 astronomical units of each other, they will form 2 stars that are gravitationally bound. This means the stars will orbit each other. If any planets form in this system, it's possible that the planets will follow an orbital path that takes them around both stars. In fact, the closest star to Earth, Alpha Centauri, is actually a triple star system consisting of Alpha Centauri A and B, as well as Proxima Centauri. These 3 stars likely formed together from the same molecular cloud. Can you imagine what it might be like to live on a planet with multiple stars? Try keeping track of sunset and sunrise times there. Whew. In second place on our countdown, let's revisit some of the most visually stunning bodies in the universe: galaxies. We can see the central band of our own Milky Way galaxy stretched across the sky on a clear night. This is because the Milky Way is a barred spiral galaxy. Some spiral galaxies are round in the middle instead, like the Whirlpool galaxy. Others lack the spiral shape and are classified as elliptical galaxies. Still others have no recognizable shape at all, like the Large Magellanic Cloud. These galaxies could have formed as the result of collisions between two smaller galaxies. Let's check the mailbag for a question. Valentina from Venezuela writes, I've read that our Milky Way galaxy will one day collide with the Andromeda galaxy. Will our solar system be destroyed when this happens? What do you think? Based on what you know about the distribution of stars and planets within galaxies, what do you think would happen when two galaxies collide? Pause the video for a moment and make a prediction. While the Milky Way and Andromeda are indeed on a collision course, it is unlikely that any individual stars or planets will collide. Why? What makes up most of a galaxy's volume? Empty space. Stars and solar systems are spaced so far apart that it would be unlikely for any to collide. The galaxies will simply merge. Though it is possible that stars, including our sun, could be flung into new locations or orbits due to gravitational interactions. So, if Earth is still around when this happens, we'll likely gain a bunch of new stars in our night sky. But for our solar system, things will continue just as they do now. For our countdown winner, let's revisit one of the most terrifying phenomena in the universe: black holes. Do you remember where a black hole comes from? It's what's left behind after a very massive star dies and explodes in a supernova. The remaining core is so massive that it begins collapsing in on itself until it becomes so dense and has so much gravity that it becomes a black hole. A black hole can be thought of as a region where the very fabric of space-time has become so steep that nothing can climb out and escape, not even light. Let's look at our last viewer question from Lizzie in Louisiana. Why do large stars only become black holes after they have run out of fuel? Excellent question, Lizzie. While the star was alive, the inward pull of gravity was balanced by the outward pressure from nuclear fusion in its core. Fusion acted as a counterforce against gravity, keeping the star stable. However, once the star exhausted its nuclear fuel, fusion stopped, and there was no longer an opposing force to resist gravity. The star's outer layers were expelled in a supernova, but the core remained. So without fusion, the core's mass causes it to collapse under its own gravity, compressing into an incredibly dense point, a black hole, from which nothing, not even light, can escape. So that's our top 5 countdown for the unit. Remember that at the end of this lesson, you'll take the unit assessment. Be sure to check out the review materials in your lesson activities first. And of course, you can always go back and review any of the lesson videos if you need a little refresher. Best of luck to you, and I'll see you in our next unit.